find y dx in terms of x. Find y dx. Find y dx in terms of x. Find y dx. Find y dx. Find y dx. Find y dx for each of the following. For each of the following expressions or functions. For each of the following. Functions. So I want to start with part A. I'll give you more parts. Part A, it goes x squared dy plus xy squared equals 4. So what we do is this. First, see the number very well and observe and tell me what it's supposed to do with that. What are we supposed to do with such a kind of a number? So when a number comes in that way, what are you supposed to do with that? You are supposed to differentiate on the left hand side, even on the right hand side. So we are going to look at d dx of x squared dy plus x y squared equals d dx of 4. So when we are differentiating such a kind of a number, what do? You can also observe this is u v product. Again u v. So you're supposed to use the idea of v du dx plus u dv dx. So you're supposed to use this idea. What are we going to do? What is our v? Is y. When differentiate x squared, when we get to 2x plus, what is our u? X squared. When differentiate y, we get dy dx. That is the first part. Plus, we come to this. What is our v? Y squared. When differentiate u, we get 1 plus. What is our u? Is x. When differentiate y squared, we get 2y dy dx equals, when differentiate 4, you get a 0. So can we move on? Now multiply what we get 2xy plus x squared dy dx plus y squared plus 2xy dy dx equals 0. So those ones with y dx, bring them together. What are we going to have? We have x squared dy dx plus 2xy dy dx plus, bring those ones with no dy dx, 2xy again plus y squared. The whole thing equals 0. Here, factor out what is common. What is common is dy dx. We remain with x squared plus 2xy dy dx. Put that on the other side equals negative into 2xy plus y squared. So, what do we do? Want to dy dx, we divide by this. What is dy dx? Dy dx becomes negative into 2xy plus y squared all over x squared plus 2xy. That's how we get dy dx. So we get dy dx, solve that. That's how we handle that. So if you want to factorize here, it's normal. If you want to push in a negative, there's no problem with that. But that's how we handle such a kind of the numbers of that nature. So after getting this concept, then you are free to get to be done with more and more numbers. So we want to move to part B. That is part A, you have already got the concept. So we want to move to part B. How can we look at dy dx? how can we look at dy dx? That's what we want now to go to part B. We started with part A. Part B was x into, you can maybe say x squared into x minus 3y equals 2. So what do we do? You can open the brackets, then you apply dy dx, we differentiate everything. So this one becomes what? X cubed minus 3x squared dy equals 2. Look at dx of x cubed minus 3x squared dy equals dx of 2. Are we there? So can we start apply? Before you move, this is a product u v. Bring the answer formula of v du dx plus u v dx. So when you differentiate x cubed, what do we get? We get 3x squared minus 3 into. What is our v? Is y. When you differentiate this, what do you get? 2x plus. What is our u? X squared. When you differentiate y, we get dy dx equals, when you differentiate 2, you get 0. So can we open? We get what? 3x squared minus 6xy minus 3x squared dy dx equals 0. Now, dy dx you can see is here alone. We can take it to the other side. Here we have got 3x squared minus 6xy equals 3x squared dy dx. What is common here? Can even replace that? What is common? What is common here is the 3x. I remain with what? X minus 2y equals 3x squared dy dx. We divide this out by 3x squared. We remain with dy dx equals 3x into x minus 2y all over 3x squared. Reduce. So what is dy dx? Dy dx equals, this one reduces, we remain with x minus 2y all over x. So you have already got dy dx. And that's how we normally handle such a kind of numbers. That was part B. We want to look at part C. What is part C saying? Part C goes to x squared plus 2y squared plus 3x equals 10 plus 2y. So I want to look at how do we differentiate such a kind of implicit functions. So solution still, we're going to look at ddx. We're looking at the solution ddx of 2x squared plus 2y squared plus 3x equals ddx of 10 plus 2y. So can we differentiate? When I differentiate 2x squared, what do we get? We are getting 4x plus, when we differentiate this, we get what? 4y dy dx plus, when I differentiate 3x, what do we get? We get a 3 equals, when I differentiate 10, I get a 0. When I differentiate 2y, I get 2 dy dx. We're now together. So those ones with dy dx, we put them on one side. What am I remaining with? I'm remaining with 4x plus 3 equals 2 dy dx minus 4y, because the positive goes and becomes a negative, dy dx. So I've got 4x plus 3 equals, what is common is dy dx. remaining with 2 minus 4y. Now, what are we going to do? We divide this out by 2 minus 4y to remain with the y dx. So we divide by this on both sides. We are getting 4x plus 3 all over 2 minus 4y equals y dx. So therefore, our dy dx equals 4x plus 3 all over 2 minus 4y. That's how we get how to differentiate such a kind of the numbers. That's how we handle most of these numbers. So we are now going to move to example 3. We're going to move to example 3. Example 3. So we are moving to example 3. It also goes for each of the following. For each of the following. For each of the following. Each of the following. For each of the following. Find the gradient of the stated curve. Find gradient, find the gradient of the stated curves, the stated curves at the point specified, at the point specified, at the point specified. At A, 3y power 4, 3y power 4 minus 7xy squared, 7xy squared minus 12y equals 5, at negative 2, 1. So they have given us this curve. This is the curve. They want us to take the gradient. And I say, when they tell you to set the gradient, they are meaning get dy dx. Strictly get dy dx. The moment you get dy dx, you have already got your what you call the gradient. Then you are free to substitute in this point. This one stands for x, this one stands for y. So you will not state them when you have not yet got the gradient. So you need to start with the getting dy dx. So I've got 3y power 4 minus 7xy squared minus 12y equals 5. So can we look at d dx of 3y power 4 minus 7xy squared minus 12y equals d dx of 5. So can we differentiate? We observe that there is uv. So when we differentiate 3y power 4, what do you get? You get 12y cubed dy dx minus 7 into what is our v? We're using v du dx. V du dx plus u dv dx. Our v is already y squared. When you differentiate x, you get 1 plus what is our u? Is x. When you differentiate y squared, what do we get? We get 2y dx minus. When you differentiate a total of y, what do we get? We get total of dy dx equals, when you differentiate 5, we get a z. So can we try to open? We get total of y cubed divided dx minus 7y squared minus 7. Is it minus 7? 7 times that we get minus 14xy divided dx minus 12 divided dx equals 0. Observe it very well. Then you are free to collect like term. Those ones with y dx, bring them together. This one has no y dx, take it in the right hand side. So we are going to have total of y cubed minus 14xy minus 12 outside divided dx, very good, equals this negative when it comes a positive 7y squared. How can I remain with the y dx class? You are supposed to divide by that bracket. So what is the y dx? So our y dx equals 7y squared all over, somebody is not writing well here. This is going to be 7y squared all over the whole of this bracket. Total of y cubed minus 14xy minus 12. Then we say that our gradient is the same as the y dx, but gradient, which they have asked, gradient is equal to the y dx. So what is our dy dx? This is the gradient. They said now they specified at what point? At x, this one stands for y. So what happens? We are going to substitute a. We are going to say gradient m equals, where there is y, put that value. It's going to be 7 into 1 squared all over 12 into 1 cubed minus 14 into our x is negative 2, our y is 1 minus 12. So can we simplify? What is 1 squared? You still get 1. 1 times 7 remains with 7 all over 1 cubed. You're going to remain with 1, 12 minus a negative times a negative, you get plus 28 minus 12. 12 and 12 disappears. What do I remain with? 7 over 28. What do I get? What do I get? We end up getting, when 7 goes how many times? 4 times. So we are getting a quarter. Therefore, our gradient which they asked is giving us a quarter 0.45. So this is the gradient of that function. So these ones here we are trying to look at the 7 into, we are substituting in our gradient into 12 into 1 cubed minus 14 into negative 2 into 1 then minus 12. So this is 7. 12 times that you are getting the 12. The negative times the negative you are getting the positive 28. Then minus 12. 12 disappears. We remain with 7 out of 28. So when you reduce you get a quarter. That's how we can easily get our gradient function on that. Part B, still we are getting on how to get stating the gradient when you are given a point on these implicit functions. We have got 2 out of x plus 5 out of y. Consider is 2 out of x plus 5 out of y equals 2x equals 2xy at a half 5. Consider I've already given the point. This is x, this is y. So how do we handle this? The same story. You can easily find the LCM to ease the work. So what is the LCM? Let's look at the solution. What is the LCM? The LCM is xy. Multiplies out by the LCM. We say xy times 2 out of x plus xy times 5 out of y equals 2xy times xy. So x equals what do we remain with? 2y plus 5x equals 2x squared y squared. Now consider I've already formed an organized equation. So look at d dx of 2y plus 5x equals d dx of 2x squared y squared. So can we look at this? When you differentiate this, here remember there is our product. That one should not forget it. So can we differentiate when we differentiate 2y, what do we get? We get 2 dy dx plus, when you differentiate a 5, what do you get? You get a 5 equals, what is our v? Our v is y squared. When you differentiate x squared, what do we get? We get 2x plus, what is our u? Our u is x squared. When you differentiate a y squared, what do we get? We get a 2y dy dx. So we are now free to open. What do we get? We get 2 dy dx plus 5 equals 4xy squared plus in 4x squared y dy dx. Now, those ones with dy dx, you can bring them together. We are going to have 2 dy dx minus 4x squared dy dx equals, those ones with no dy dx, we will put them together, 4xy squared minus 5. What is common is dy dx. We remain with 2 minus 4x squared dy dx equals 4xy squared minus 5. So what do? We divide by this. So what is dy dx? Dy dx equals 4xy squared minus 5 all over 2 minus 4x squared dy. So this is our dy dx, and we say that dy dx is the same as the gradient. So we shall go gradient m, gradient, we are using as grade m. Gradient m equals, they give you the point they specify. Where there is x, you put that. So our gradient m equals 4xy squared minus 5 all over 2 minus 4x squared y. So what I'm going to do is this. At the point, a half, at a half, then 5. This is standing for x, this is standing for y. You know coordinates on the Cartesian plane. Then we are free to substitute it. We say 4. Why there is x, bring a half. Okay. Why there is y, put 5 squared. Then minus 5 all over 2 minus 4 into a half squared times 5. So we go ahead and reduce it. A half goes in that to, what is 5 squared? 25. Then minus 5 all over 2 minus, what is a half squared? A half squared, you get a quarter. A quarter, this is that we remain with only 5. What is it now? This is 50 minus 5 out of negative 3. What do we get? Negative 45 out of 3. So gradient m is negative 45 out of 3. So this is the gradient when you are given those parametric equations. That's how we handle such a kind of a number. So we are going to go to part C. We are now moving to part C. Same story. How can we get the gradient? How can we get the gradient when you're given an implicit function? And look at how can we get the gradient when you are given an implicit function. Well, I've got another one is part C. X plus 2y power 4 equals 1. Part C is saying x plus 2y power 4 equals 1 at 5, -2. So you can see I've already given the point, the coordinate is already 5, -2. That means from here, you are free to first get for me what we call the y dx solution. So you're supposed to look at d dx of the left hand side, which is x plus 2y power 4 equals d dx of 1. So how do we get this one? We get 4 into, we write this one, x plus 2y, deduct 1 power 3 times, we differentiate inside. What do we get when differentiate x? We get 1. When differentiate 2y, we get a 2 dy dx. The whole thing equals, when differentiate 1, you get a 0. So now we are free to push in and open. What do we get? 4 times that, we get 4 into x plus 2y power 3 plus, this times this, we get 8 into x plus 2y power 3 dy dx. The whole thing equals 0. So 1 remains with y dx. This one is a positive. When the positive comes what? A negative. We're going to remain with 8 into x plus 2y power 3 dy dx equals -4 into x plus 2y power 3. So we are free to divide by this. We are free to divide by this. We are free to divide by this. So what I'm going to do is this. After dividing by this, what do you come out with? What is the y dx? Y dx becomes -4 into x plus 2y power 3 all over 8 into x plus 2y power 3. This and this reduces. So what is our gradient now? Gradient equals -half. That's what we are getting. See, here there is no need of substituting in simply because we did not get any variables remaining, where you could easily substitute that. So that one was there for you to test that did you get the concept very, very well. And those questions are always common. So when those questions comes, you need to always be very, very, very serious with them. So we are going to go to another example, which goes, I'm going to go to another example. Let me hope that you have written this. I'm going to go to another example. I'm going to go to another example. I'm going to go to another example. This example goes, given that x squared, given that x squared plus xy plus y squared, given that x squared plus xy plus y squared, x squared plus xy plus y squared minus 3x minus y equals 3, show that show that dy dx, show that dy dx equals, show that dy dx equals 3 minus 2x minus y all over x plus 2y all over x plus 2y minus 1. So they have given us this parametric equation, and they want us to show that after differentiating, after getting dy dx, you can easily obtain that one. And these questions are always common, and they want to test your capacity. That are you doing, and avoid gambling these numbers. Always follow the procedures which I have given you. Always obtain, differentiate each and every particular. Then at the end, you will end up getting what is required. Let's look at the solution. We have got x squared plus xy plus y squared minus 3x minus y equals 3. So we are going to look at d dx of this equals d dx of this. So when you differentiate x squared, remember here there is our product uv. Here, that one, don't forget it. When you differentiate x squared, what do we get? We get 2x plus, what is our v? Is y. When you differentiate x, you get 1 plus, what is our u? X. When you differentiate y, you get dy dx plus, when you differentiate y squared, what do we get? We get 2y dy dx. When you differentiate 3x, you get 3. When you differentiate y, you get dy dx. The whole thing equals, when you differentiate 3, you get a 0. So those ones with dy dx, bring them together. Or we first open multiply by, we get 2x plus y plus x dy dx plus 2y dy dx minus 3 minus dy dx equals 0. And then those ones with dy dx, bring them together. So, and those ones with no dy dx, bring them together. So we're going to have 2x plus y minus 3 plus those ones with dy dx, bring them together, x dy dx plus 2y dy dx minus dy dx equals 0. So what we're going to do, we're going to have 2x plus y minus 3 plus, we factor out dy dx, we get x plus 2y minus 1 dy dx equals 0. One, take this one in their side. How do we take this one in their side? This one element is a pairing because when the equation becomes what? A negative. We're going to remain with x plus 2y minus 1 dy dx equals a negative into 2x plus y minus 3. We divide by this. What is dy dx? Dy dx equals, push in. We are going to have a negative 2x minus y. A negative times a negative, we get a plus all over x plus 2y minus 1. Now, can we rearrange in the way they have told us? We say therefore dy dx equals, we need to arrange it in that manner. So one side is the one which is positive. We are going to say 3 minus 2x minus y all over, come here, x plus 2y, x plus 2y minus 1 is proved. So we have already proved that one. We have already shown the way how they told us to believe up to that point. And these numbers of proof there, you can see, have followed my steps and the derivative has come out. When you gamble on them, then you are going to get problems. So you need to be very, 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 very keen and very, very serious with them as far as these ones are concerned. and practice more. Practice more. Those numbers are there waiting for you. And I told you that mathematics is all about practicing. The more you practice, the more you become perfect. But if you don't practice, I want to repeat this one. If you don't practice, you will not get it. Even the little which you have been passing, it will also become a problem to you. So we are going to look at now more examples on these ones. More examples. More examples. More examples. More examples. More examples. We look at more examples. I'm just saying examples. As example. Example 5. Given that x squared y squared plus 4xy plus 6x minus 5y equals 10. Find dy dx. Find dy dx. Class, can we go together? The question goes, given that x squared y squared plus 4xy plus 6x minus 5y equals 10, find dy dx. Find dy dx. Let's look at the solution. How do we handle this? We have already got dx of x squared y squared plus 4xy plus 6x minus 5y equals d dx of 10. Now, you can see these ones are having element of product. You can say this is my u, v. So you can write it somewhere v du dx plus u dv dx. So can we apply what is our v on this one? Our v is y squared. When differentiate x squared, what do you get? You get 2x plus our u is x squared. When differentiate y squared, you get 2y dy dx plus 4 into what is our v is already y. When differentiate x, you get 1 plus what is our u is x. When differentiate y, you get dy dx plus when you differentiate 6x, you get a 6. When you differentiate 5y, you get a 5 dy dx. The whole thing is when you differentiate 10 is a constant, you get a 0. Then from there, we open the brackets. What do we get? We get 2x y squared plus 2x squared dy dx plus push in, what do we get? 4y plus 4x dy dx plus 6 minus 5 dy dx equals 0. So from there we collect like terms. Those ones with no dy dx, bring them together. So we're going to have 2xy squared plus 4y, then plus a 6, put them together. Those ones with no dy dx will also bring, with dy dx will bring them together. We say plus 2x squared dy plus 4x minus a 5 dy dx. The whole thing equals 0. Then these ones you can see it's a positive. When it goes up becomes what? A negative. What do we remain with? 2x squared dy plus 4x minus 5 dy dx equals, take it there, negative into 2x y squared plus 4y plus 6. We divide by this, so we remain with dy dx. So what is dy dx? Dy dx equals negative into 2xy squared plus 4y plus 6 all over 2x squared dy plus 4x minus 5. So you have already got your dy dx. If you want to push in the negative, you have no problem. But this is the way how I'm expecting you to always be doing these and these numbers, always and often. Calculate this way, and this number, it carries 5 marks. So never fail to fetch these 5 marks when you have already given you what is required. So we are now moving to another example. Yes, another example until when people have already got the concept. So we're going to go to another example, and this one is involving parameters, so that people conversant with these parameters. That's where we are now moving. So we are now moving to. So we are moving. The question goes, example, example 6. Given that x equals 2t cubed plus 6t, comma, y equals t power 4 minus 2t squared. Find the y dx in terms of t, and y dx in terms of t. So they have said find y dx in terms of t. So what do we do is this. Look at the solution. These now are parameters. So what we're going to do, we have got x equals 2t cubed plus 6t. So can we look at the x dt? The x dt. We're differentiating this one with respect to t. What do we get? We are getting 6t squared plus 6. So this is our dx dt. So what is our y? Our y equals t power 4 minus 2t squared. Can we look at the y dt? The y dt becomes what? What is the y dt? You are getting 40 cubed minus 40. 40 cubed minus 40. Then, after getting the y dt and the x dt, we are supposed to use our chain rule. Using the y dx equals the y dt times dt dx. What is our dy dt? Our dy dt goes 40 cubed minus 40 all over, what is the dt dx? We said we take the reciprocal, all over 60 squared plus 6. Then here we are free to factorize out. We are free to factorize out. Our dy dx equals, what is common up is a 40. 40 into t squared minus 1 all over, what is common down is a 6. 6 into t squared plus 1. So what is it? 2 reduces, we remain with 2t into t squared minus 1 all over 3 into t squared plus 1, which is our dy dx. So this is how we get our dy dx in terms of t when you are given the parametric equations. Still, we are going to do, because there is one who said did not pick well on this one. That's why we are going to do another example related to these parametrics, so that we are done with this concept. Then we shall proceed to another concept. That's how we always do such a kind of the numbers. That's how we always do these numbers. So we are now going to proceed to example 7. Example 7. Given that x equals t cubed over 1 plus t and y equals t squared over 1 minus t. Find the value of dy dx in terms of t. Find values. Can we read the question together? Given that x equals t cubed all over 1 plus t and y equals t squared out of 1 minus t. Find the value of dy dx in terms of t. You can see they have given you also parametric equations. So they want us now to get the value of dy dx in terms of t. So what we want to say, we have got x equals t cubed out of 1 plus t. This is u, this is v. This is our quotient rule. We shall say dx dt equals v du dt minus our u dv dt all over v square. What is our v? Our v equals 1 plus t times. What is our du dt? When you differentiate this one, what do you get? 3t squared minus. What is our u? T cubed times. What is dv dt? 1 all over. What is our v squared? Is 1 plus t, the whole of it squared. We go ahead. What does it become? Open. This becomes 3t squared plus 3t cubed minus a t cubed all over 1 plus t, the whole of it squared. What does it become? This one becomes 3t squared plus 2t cubed all over 1 plus t, the whole of it squared, which is equal to dx dt. So you can see we have used our quotient rule to obtain the x what? dt. So we are also going to obtain the y dt using the same quotient rule. We have got y equals t squared out of 1 minus t. So the same story, we are going to, using quotient rule, we shall say using dy dt equals v du dt minus u dv dt all over v squared. Our quotient which last time we derived. What is our v? This is u, this is v. What is our u? What is our v? 1 minus t times. What is the u dt? You are getting 2t minus what is our u? T squared into -1 all over. What is our v? 1 minus t, the whole of it squared. What do we get? We get 2t minus 2t squared plus t squared. A negative is a negative, get a positive all over 1 minus t squared. So what are we going to do? What are we having? Collect terms, what do we get? We get 2t minus t squared all over 1 minus t, the whole of it squared. So this is our dy dt. Then we shall go ahead and using our change rule. We shall say using dy dx equals dy dt times dt dx. So what is our dy dt? What is our dy dt? Our dy dt becomes 2t minus t squared all over 1 minus t, the whole of it squared, times what is the t dx? Remember, we say we take the reciprocal, which becomes 1 plus t, the whole of it squared, all over 3t squared, 3t squared, plus 2t cubed, plus 2t cubed. So we proceed to simplify where possible. Go ahead and simplify where possible. We need to go ahead and simplify where possible. Like by messing up, what is common is a t. So we are going to y dx. What is common is a t into 2 minus 1, 2 minus a t into 1 plus t, the whole of it squared, all over 1 minus t squared. What is common is the t squared there. Times t squared into 3 plus 2t. 3 plus 2t. So, what happens with t reduces, we remain with 2 minus t, again into 1 plus t squared, all over 1 t has reduced, we remain with t into 1 minus t squared into 3 plus 2t, which is our dy dx, which is in terms of t. That's how we normally calculate these numbers, and it must be your concern to always do more and more. Because when you don't do more and more,